Hello, welcome to the GSSO training module for the Cisco ASA firewalls. My name is Jerry Lin. I am a consulting systems engineer in the Enterprise West region. And today's session or module will be on ASA design. Let's begin by looking at the learning objectives. So at the end of this module, you should be able to position and design the ASA product family for small, medium, and large customer networks. Also should be able to architect the ASA in various parts of the network, specifically the perimeter and the data center. And last is to be able to integrate the ASA into the Cisco portfolio in terms of TrustSec to offer a customer a complete security solution. So let's start by looking at the ASA portfolio here. On the left-hand side, we have the ASA 5506 and 5508 as an example, and they're positioned for the small office, home office. And as we move to the right, to the upper right here, we have the ASA 55 in the middle in terms of about 1 gig or plus of next-gen firewall performance. And if we keep moving further up to the right, on the top there, we have the ASA 5585 and SSP60 as an example. SSP60 is a 20 plus gig next-gen firewall, and it's very well positioned for the data center. Now we also have an additional firewall that's been added lately. It's the Firepower 9300, and those are higher end data center and ISP appliances that's capable of scaling up to about 180 gigs of next-gen firewall and IPS solution. So it's very, very fast. Now on the lower right-hand side, for virtualization, of course, we have to play there. So we have an ASA virtual platform that's available, okay, and it's available as a ESX image or a Linux VM as an example, and I'll cover more about that later on here. But overall, we have a very broad portfolio to be able to support customers' needs from small to large enterprise networks. Now, what makes the ASA different? So let's begin by looking at several differentiator points. First is the AnyConnect client. The AnyConnect has been deployed over 100 million clients worldwide, and that number is continuing to grow. So it's extremely popular. It is a strong point for Cisco in terms of the ASA platform, and we should continue to push forward into the industry there. The business outcome obviously is helping us to produce or helping customers with business productivity through mobility, right? And we are evident of that at Cisco with a huge sales force running AnyConnect in all of our devices. The other component below is the ASA clustering. ASA clustering allows our customers to scale security, meaning that they can deploy 1, 2, 3, 4, 5 ASAs in terms of high performance within the data center, and that basically allows them to pay as they grow for their business. Other features like layer 2, layer 3 integration, and that means routed mode, transparent mode for firewalls for the data center. We're very well positioned for that. All those features are available, and we simply will allow the customer flexibility to deploy wherever they need and to help lower implementation costs. VXLAN is also supported because of virtualization, granular traffic segmentation or microsegmentation, so that's also supported to help scale in terms of more than 4,000 VLANs, but we now call it VXLANs. ASA is also the platform, the base foundation platform for next-gen services, from SourceFire, next-gen firewalling, advanced malware protection for AMP. Okay, those are all threat-centric security options, and that could be installed on top of the ASA, and I won't go into details in here because that is the topic for another module. Okay, and the last piece at the bottom is SGTs, or security group tagging. It is our TrustSec solution, and I'll talk about how ASA supports TrustSec or SGTs to help our customer enforce a consistent policy and reduce the complexity across the enterprise. The first design we're going to look at is a simple one. I call it remote access SSL VPN, and that's simply because we have a huge install base in terms of AnyConnect, over 100 million endpoints. And this is true for the mobile workforce, and that it's adopted by the entire industry. So with the AnyConnect solution or remote access solution, we can build a high available and scalable design which supports multiple operating systems: Windows, Mac, OS X, iOS, Android, Linux, etc. Offers in multiple modes in terms of full tunnel client, so you have to install the client, or a clientless mode. It's all available. And other advanced features like session persistence, trusted network detection, optimal gateways. These are all very common and popular features that we deploy to help the user experience to be a good one. And trusted network detection is, for example, is a good way of having the endpoint when it moves from the home office with encryption on, when it moves into the office, it automatically detects it is in the corporate office, and then now the AnyConnect encryption will automatically shut itself off because it doesn't need to encrypt anymore due to that it moved into a corporate network. Okay, so these are all advanced features that we offer, and many of our competitors do not have this. And AnyConnect, as I mentioned, it comes in the full tunnel client, so that means you have to install an agent on Windows, Mac, or iOS as an example, or Android. So it's something you have to install. Okay, and that comes IPsec version 1 and version 2, as well as SSL with many features, versus the clientless SSL portal in the ASA. And the client SSL portal is something that there's no agent ever installed. The endpoint simply uses the browser. They will authenticate as they normally do, single factor or dual factor into the ASA, and then resources are presented at the portal, right? It's all configurable by the administrator, so it's very, very flexible. And one popular use case with a clientless portal is Citrix integration, or VDIs, with Citrix. And ASA can talk to Citrix today. Okay, and so that means we're the gateway now for the AnyConnect client, for the endpoint trying to connect to Citrix. Okay, they can go through the ASA as a gateway for that. From a ASA VPN design perspective, we support load balancing, and we do this today at Cisco as well, that we can take a cluster of ASAs and stack them together as one logical entity. So there's a cluster master, and and the rest of our considered slaves, and the cluster master will redirect traffic to all the other cluster members. Now this is VPN clustering, so it's not the same technology as ASA firewall clustering. The functionality is the same, just applied to different technologies, but this is for VPN only. And if the cluster master should ever fail, there's an election process to select a next cluster master within the stack, right? So the entire cluster is never down at any one point if there's a single point of failure. Okay, and failover can also be configured as well. Now in this case, all the units within a cluster are active, so they're all serving sessions, connecting sessions for endpoints coming in, and there's really no hot standby or stateful failover in this case, because every single ASA is hosting connections, and if one fails, all those sessions would disconnect, and it's up to the endpoint to reconnect back into the cluster and connect to another active ASA within a cluster. Now if you want high availability in terms of stateful failover, now we can pair up ASAs within the cluster. Okay, so you can have a pair of ASAs running in active standby mode, and in this sense the standby ASA will resume all the current sessions in the active ASA should it fail, and now the client will never expose or never experience any downtime if the active ASA fails. Okay, and all this really means is that we can provide high availability as well as clustering together. The customers simply have to purchase more ASAs to configure them in active standby mode. One thing I want to point out is that hardware should be identical when we're putting them in a cluster or specifically in a HA mode, right? They need to be identical in terms of the model, the physical memory, the software, etc. The next design I want to talk about is perimeter security, and this is the popular one with ASAs. Been deployed many years now, and this is at the network edge, right? This is a simple, robust, mature, and solid solution of inside interfaces, outside interfaces for multiple ISPs, as well as DMZ interfaces on the right-hand side to handle public servers, web servers, database servers, DNS servers, etc. Okay, in this case, ASA Very robust, rock solid, running in active standby mode or active mode with clustering if you choose to now with ASA 9.x code. At the network edge, we're simply running layer 3, layer 4 stateful firewall, provide edge routing. Dynamic routing is available as well. We can do NAT, all different versions of NAT. Source NAT, destination NAT, it's all supported, and simply it works. Now, if a customer requires higher level inspections such as next-gen IPS, application visibility control, URL filtering, that is all part of the AMP or Firepower solution set. I won't go into here because that's training with another module. The next design I want to share with you is the ASA clustering. Right, this is a sweet spot of the ASA within a data center. And let's take a look at cluster. What does it do for the customer? Well, it simply is a pay-as-you-grow model, and it's high availability or available and scalable because customers simply can stack more ASAs within a cluster as they grow their business. It's available in a single or multi-context mode, so it's very diverse, and it integrates with the Nexus data center switches via VPCs, and Nexus switches meaning Nexus 7Ks and Nexus 9Ks. And the Nexus 7K is the most popular platform where we can run a VPC, right? And as shown here is that within the data center, typically there are dual switches for a distribution or a core. In here we're labeling S1 and S2, and they run a VPC link with another. Now the ASA via Ether channel and LAC-P can connect to both switches. So now the ASA sees both switches as one destination hop, one destination switch. And in this sense, the ASA is sending traffic up both links. Packets are just going up and down both links to both switches, and in that sense allows you to scale the performance, right? Customer can get the most out of what they invested in a per ASA or per cluster. So you essentially double the bandwidth because you're using both links. Now from a clustering scalability perspective, we're in the 9.x code now. If there's no asymmetry within the data center, we can pretty much do a linear growth at 16 ASA is our maximum, so you can take 16 ASAs times 20 gigs to get you 320 gigs. But if you have asymmetry, or the tested average or throughput is about 70%. Okay, so it'll get you about 224 gigs of real-world TCP traffic. And same thing within the concurrent session, also scale up as you add more add more ASA within a cluster, and same thing with the connection rate. So you guys can take a look at these numbers, but at the end of the day, we have a very solid solution to help customers scale to their needs in terms of millions and millions of connections and gigabytes, etc. Clustering works in this way. Clustering has multiple roles that makes up the solutions. The first one, there's a flow owner, and the flow owner is the unit that receives the connection from the client. So traffic comes in, the owner picks it up, and the owner picks up that flow, okay, and it updates the director, okay, as backup. And the flow director will back up the owner because it keeps track of the state sessions of the owner, so it knows about, okay, ASA number 1 has all of these flows, and I'm simply a backup for that ASA, okay. And the flow director can also redirect traffic if another flow, if a flow comes in to another ASA and that ASA didn't pick up the original handshake or original session, it'll talk to the director, and the director will tell it where to forward the flow to. And I'll give you an example shortly coming up here. So the third portion is the forwarder. The forwarder is what I just talked about, where an ASA receives a connection that it didn't own initially. It's seeing the second or third part of the three-way handshake, so it didn't see the first part and didn't know, it doesn't own it, so it didn't know what to do with it, so it will query the director of what to do with that flow, right? And that typically is the situation, asymmetric flow here. Now all the ASAs could be owners, all the ASA could be forwarders, and all the ASAs could be directors, right? It is the Cisco's algorithm or clustering algorithm that figures it all out. So the entire cluster itself is highly available, highly scalable, where there's no downtime at any one point. Everything simply works. Backups are available for all of these roles. So let's take a look at how clustering works. Say that a client sends traffic, packet N, and packet N+1 returns back from client to server. So this is an easy one. The client traffic gets load balanced by ether channel on the switch, which is a very simple and cheap solution. It sends it to the second ASA called the owner, and the flow comes back with symmetric flow, and things are good. Now, what happened if that ASA fails, it loses power? Well, the client is continuing to send traffic, but now because of load balancing will send the flow for packet N to another ASA, and say the return traffic from the server back to the client actually goes to another ASA, two separate ASAs, and this term is ASA Y. Okay, well, what would they do with it? So now the ASA X and Y are considered forwarders. They're not the original owner since they didn't see the initial handshake. So they will query the director within the cluster and ask him where the flow came from. And now the director says, oh, the original owner is down. You guys, ASA X, ASA Y, you guys can pick it up, or it can just tell ASA X to be the main owner to resume the flow here. So in this case, the director tells ASA X to be the owner, so ASA X picks up the flow. And then, but it also tells ASA Y that, okay, redirect the flow, because you're not the owner, you're the forwarder, redirect your flow to ASA X, because he or she is the owner, so now all traffic is resumed. Okay, so it's very, very efficient, and it works very smoothly. Clustering, in terms of configuration, I won't go too much into the details in terms of time, so you can look at the configuration, but from a configuration perspective, all the links are, you can see they're dual home, so we create them in a cluster via port channel. So port channel is nothing new here. And then within a port channel, we simply assign an IP address block so that every single ASA, its interfaces in routed mode as an example, in this case, they will all have an IP address. Okay, so it's in a sequential IP address for within a cluster. And the same thing with the cluster control link, or excuse me, the management link here. Every single ASA also has a management interface, and they all have IP addresses, and there's of course a master unit that assigns these addresses to all the other ASAs. So it's all individual ASAs, but they work together as one logical entity to provide the clustering capability here. And this is something that Cisco is doing that none of our competitors out there can do today. The next solution we're going to talk about is the design solution for TrustSec integration. And this is where the ASA now is picking up TrustSec functionality in terms of enforcing role-based access control. Okay, and that's understanding SGTs. And of course, the TrustSec goal is to help a customer increase security and reduce operational complexity and expense. Okay, and this is done in two flavors. The first offering is with an agent called Context Directory Agent. In short, we call it CDA. And the second option is called Identity Services Engine. In short, we call it ICE. And I'll talk more about that coming up here. So the first option is to do identity firewalling using ASA, is using the CDA, or Context Directory Agent. So your customer will have to install the Context Directory Agent as a software, as a Linux VM that they download from CCO. As long as they have a valid support contract, they download it, they install it. CDA talks to Active Directory via Windows Management Interface, or WMI, to grab user information, user names, as well as IP address that's been reported by Active Directory. Now, at the same time, the ASA, in terms of identity firewalling, needs to get identity beyond just the IP address that it sees from the packet. So the ASA will build a connection to the CDA and says, I have these IP addresses. What are the usernames within AD that are associated with those IP addresses? Give them to me, and it downloads them to the ASA. So now the ASA has a full mapping context for the user flow. We see the user name from Active Directory, we see the user IP address and traffic, and that's an entire flow, and that allows the administrator to build a access policy or access control list based on identity, or based on roles, right? They no longer have to track user based on IP addresses anymore, because users are mobile, IP addresses are changing, ACLs gets big in that case. By leveraging identity, you simplify and reduce the complexity in your access control lists. So that is the one simple and cheap way of doing it. The second way is our preferred way. It's more of an enterprise version that works much better, and that is done via ISE, Identity Service Engine, and that's using SGTs. So let's take a look at this example here. In this example, you have an employee could be coming in via wire or wireless with .1x coming in on the left-hand side. The employee enters the network, authenticates, user name, credentials, password, etc. gets presented to the network and it gets authenticated and passed on to ISE for authentication. ISE at the same time on the right-hand side identifies the user, captures all that information and assigns a specific role or SGT tag value. And it can tell the switch to tag the packet if it can, okay, as well as wireless LAN controller. At the same time, ISE can now build a relationship, a connection to the ASA in the middle of the design here about that SGT table as well. So ISE will tell the ASA that these are the SGT tables, roles available in the network. So as you see packets coming in from the left as an employee coming in, you can now also enforce an access control list or access policy based on SGT values or identity instead of IP addresses. And as I mentioned, because of the mobile workforce, controlling user access with IP address is very difficult, right? You result in a huge access list with IP addresses across your networks. Well, you no longer need to do that. Your source IP address column could be any, and we're keying off an access list based on security groups or security group tags, right? And that's got management SGTs or employee SGTs or contractor SGTs and things like that. Okay, and here's just a screenshot of an ASA using ASDM to control, create a policy based on SGT values. The next design we're going to talk about is L2, L3 virtual firewalls within a data center. This is again very popular because customers use this to help them deploy solution very quickly within the data center. So we're leveraging virtual firewalls, and what that means is that we can take a physical firewall and carve them up into multiple virtual firewalls. Okay, and this means that with multiple virtual firewalls, you can have multi-tenants. So you can have one virtual firewall be assigned to one business unit or one customer, and a second virtual firewall assigned to a second tenant or a second customer, and so on and so on. All individual firewalls are independent. There's no policy sharing or inheritance of any policies, and they can be in mixed mode or transparent mode. It's completely up to the administrator. Okay, and we can also enforce a resource allocation control of no one virtual firewall consumes more resources than the other virtual firewalls. And we'll get more into that upcoming here. From a mode of operation within a data center, we typically prefer transparent mode versus routed mode. Routed mode is traditional, meaning you just put in an IP address on every single interface, and the firewall is viewed as a hop, a layer 3 hop. But in transparent mode, we can quickly drop an ASA into the data center without having the data center or having the customer network to change their IP addressing. We simply drop the firewall into the middle of the flow, turn on bridging, and the endpoints of the servers know they don't have to change anything. They simply continue the forward traffic as they do. So that is our preferred and the quickest, the most efficient way in terms of best practice data center design. And then the mixed mode, mixed context mode, we support that, so you can have multiple contexts in router or transparent mode. Either way, it's all available. Okay, from a virtual firewall design perspective, we can take a large ASA 5585 SSP60 as an example and deploy them up into, or carve them up to 250 virtual firewalls. Okay, and again, all these virtual firewalls are independent. They have their own policies. Whatever they do is independent. Nothing is ever leaked over to the other virtual firewalls, and you can assign each virtual firewall to a different tenant so they can log into their own virtual firewall and create their own policy if they wanted to. Okay, so that's the scalability and the power of the ASA virtualization. From an administrator perspective, how does it work? Well, the administrator logs into the ASA and into the admin context, and then it's within the admin context the administrator sets up all the system parameters. They'll allocate virtual firewall number 1, number 2, number 3, etc. Allocate the resources, the memory, the number of interfaces, the connections, etc. to this individual firewall. So the administrator has to do that up front there. And then within an ASA, this is just some design limitations and guidelines that an ASA is limited up to 1,024 total interfaces or VLANs. Okay, so if you're going to be carving out multiple virtual firewalls, you have to take the 1,024 VLAN and divide that across how many virtual firewalls that you have. So my point is basically you just need to work within the limitation, okay, in terms of how you allocate the VLANs. And within each virtual firewall, we can now expand up to 250 BVIs or bridge groups. So that's a virtual firewall, independent bridge groups. Before the 9.1 Xcode, I believe, it was only 8, but through customer requirements, and we've now been able to scale up to 250. But again, because of 250 BVIs or bridge groups within a virtual firewall, you have limited VLANs to map to those interfaces. So just be careful there. So as of the recording of this session here, a remote access VPN is not yet supported from a virtual firewall perspective, and only site-to-site is supported in the central site-to-site supported in the central virtual firewall there. But just to let you know, there is a roadmap that's coming up very shortly that we will be supporting remote access for multiple virtual contexts. And this is just again a quick example of configurations where we deploying multiple virtual contexts. We allocate interfaces and create the port channels and assign different VLANs within the port channel. Okay, and so it's really just trunking, and then we map those interfaces to different virtual contexts. So you have to go in as I mentioned, as a system admin within the admin context, and you create contexts. PTNR for partner context, create another context for BYOD, create another context for PCIs as an example, and you see within each context we allocate the interfaces for port channels and VLANs and things like that, and that's how you control what each individual virtual firewall can get in terms of resources, including the configuration file that you define for disk 0 within each context. And then once you have allocated those virtual contexts, you can issue a command. You can change. That's the command. It's called change to context to a partner context. As an example here, once I change into the partner context, when I do a show run, I see a full-blown ASA as I would do a regular ASA. I see the interfaces, I see the host name, password, etc. All the commands are all the same. The last use case we're going to talk about is data center virtualization, and that is virtualized security in the hypervisor, okay, to allow customers to scale deployments and yet maintain security. And this again is multi-tenant in the hypervisor or virtualized world, and that means typically requirements will be that the customer will still need routed or transparent mode and some sort of resource allocation. Okay, so with that, we have the ASA virtual appliance available today, and it's been out for a little while now. And the ASA virtual firewall is a full-blown ASA running in a virtual instance. Okay, it's just a software image, no physical hardware, and it runs in several virtualized platforms, and I'll get into that in a second here. But basically, each ASAV, there are different sizes, and they can have 10 virtual NIC interfaces, and including VLAN tagging supported. They have near feature parity with all ASA hardware. Okay, and it just really supports SDN functionality, dynamic routing protocols, IP version 6, the REST API for programming, TrustSec, zone-based firewall. All these features are supported, including high availability or failover active standby. Those are all available there. The only thing you can't do is that you cannot expect a virtualized ASAV to run virtualization within itself, because that simply doesn't make sense. So if you need to virtualize it, you simply deploy more ASAV instances. Now, also, as I mentioned earlier, the ASA supports remote access. Well, ASAV does the same thing. It can support the remote access full tunnel client or clientless VPN. It's all supported, okay, because it's simply just a full-blown ASA running in a software instance. And these are the models I talked about, small, medium, or large, I call it. There's ASA v5, ASA v10 and 30, going from 100 megs to 2 gigs for the ASA v30 flavor. And if you download the ASAV, install it, the ASAV without any license allows you to run it in a lab at about 100K throughput for simply for testing, right? It's a very practical and easy way to deploy ASAV just to test out features and get small performance numbers throughput. Very, very quick. From a deployment perspective, it's nothing too different from what we would do in the physical world today, right? And that means if you deploy ASAV in a routed mode, you have an outside interface, you have an inside interface, you have a PCI or DMZ interfaces. Simply assign IP addresses to all those interfaces, enable routing, and off you go. It's very, very straightforward there, okay? And dynamic routing protocol is also supported. And same thing with a transparent or layer 2 firewall mode. If you need to deploy it within on the hypervisor to do VLAN mapping or bridging, go ahead and create these interfaces inside and outside, create the virtual bridge virtual interfaces and map the traffic through the ASA without changing IP addresses. And this is the most effective way we discovered, because it allows you to drop it into the network, into customers' existing data center without having to re-address their data center IP addressing scheme. ASAV definitely supported on VMware ESX, and there's different types of mode in terms of ESXi mode or VI mode, and that simply just means that there's different configurations part of the setup, okay, to help ease the deployment and to help the user with a speedier deployment, okay. And if ESX is not the flavor of choice, you can run them in Linux in terms of KVM, so ASAV is supported in KVM as well. And there's additional features like enable day zero configuration, where you grab a configuration file ahead of time with all the necessary parameters, IP addresses, and things like that, and compile that with the KVM version of the ASAV and deploy it. And now you have a very, very quick, speedy deployment with day zero configuration bundle ahead of time. Right? It just helps with rapid deployment there. And these are the Linux parameters that you can take a look at. As we wrap up here, these are simply resources available for troubleshooting and training. Lots of information available today on the Cisco.com webpage. And for the Cisco internal folks, there are lots of Cisco TAC training, Tech Zone articles that talks about troubleshooting as well as some more detailed training courses available via the TAC organization. So let's summarize what we talked about today. So we review in the beginning how to position the ASA from small, medium, or large, because there's such a broad portfolio there. And then we also talked about the ASA in various parts of the network, specifically the perimeter, right? That's the tried and true deployment, as well as the data center using technologies like clustering and virtualization, okay, or virtual firewalling to help our customers scale deployment within a data center. And last, we also talked about the ASA in terms of security group tag and trust sec for identity access control. Okay, and that's integrated with Identity Services Engine and as well as the rest of the network. Thank you for your time.